All right, we're on 0.1, the green worksheet talking about number 4, and this is D, is that right? 4D, and we have this, 0.416 repeating. Now, I want you to be aware that this is not the same as if you were given 0.416 repeating. All right? These are two separate decimals. They're different. You would not do the same thing to solve each of them. In the one on the left, I think we can just set it equal to x and multiply both sides by 10. In the one on the right, you're going to have to multiply both sides by 1,000. All right? So let's do the one on the left. And here's why I think you can just multiply by 10. My advice to you yesterday was to count the number of digits that are repeating. Or how many numbers does that bar go over? How many? How many bars is this? How many numbers is this bar over top of? 1. If it's 1, you multiply both sides by 10. Okay? Only the 6 is repeating. So it only bumped the decimal over one place. If we were doing the problem on the right, you would set x equal to the whole thing, 0.416, all of it repeating. And when I ask you the question, how many numbers is that bar over, your answer would be 3. So you need 3 zeros on your multiplier, and you would do 1,000x equals 416.416, etc. Let's finish that one up, because these are more common, I think, that you'll see. And the one on the right, which, by the way, is not 4D from the worksheet, it's a problem I made up. That's similar. All right, you would subtract this original equation from both sides. Take away x on the one side, and take away the 0.416 repeating part on the other side. When you put a big line under it, what's 1,000 x's minus one of them? 999 x's. What's 416.416 repeating minus the 0.416 repeating part? Just 416. This goes away, and you're left with simply 416. The repeating part cancels, and we're almost done. You would divide by 999, and you're done. Okay? 416, 999. If you could reduce it, reduce it. If not, stop. Now the one on the left, let's see what happens. This is the actual problem 4D on the green worksheet, so let's finish it up. We're going to repeat the process of taking away our original equation from both sides. Now the difference is the part after the decimal point doesn't completely match up, right? It doesn't completely match up the way it did before. You see how the 0.416 completely matched and went away? It looks a little bit different this time. So let's see what we have. On the left, 10x take away 1x is 9x. On the right, oh boy, here's what we have. Let me just write it out. We have 4.1666, right? Minus 0.4166, etc. The 4 minus nothing is 4. Well, we actually have to borrow here. But what I'm going to do is I'm going to separate it right here. Okay? To the right of that line, everything is the blank. Same, right? If you're subtracting all of this sameness, right, from all of this sameness, they're the same. If you subtract them, what happens to them? They do not exist anymore. They cancel. So all those 6, 6, 6, 6, 6, 6 repeatings go away. Can you do $4.16 minus 41 cents? Sure. Go ahead. I think you get 375, right? So we can still do this, everybody. We just happen to get a decimal this time, but that's okay. Simply divide both sides by 9, but don't stop. 3.75 ninths is kind of a no-no in the math world. You're mixing decimals and fractions. So we typically say, let's expand it by moving that decimal 2 to the right. So what would show up on the bottom? 900. That's a good answer. If you feel it can be reduced, reduce it. I think it can. Because 3 goes into 375, 125. And 3 goes into 900, 300 times. And then you can keep reducing it after that. So reduce it, but before you start reducing this fraction, check it. Is 375 over 900 0.416666666666? If your answer is yes, we're done.